A lot of times they'll be darkened in. That means they're parallel. Right? That means they're parallel. When lines are parallel, what are they?
They're not.
Yeah, they don't cross. They're never going to cross. So first thing we're going to talk about here is what's called parallel lines. And parallel lines, I'll just move this off here real quick. Instead of using the word parallel all the time, you've seen that, right? That stands for parallel. It's like diagonal lines like that just means parallel. So parallel lines are lines within the same plane, correct, that don't intersect. Again, I'm sorry that I've got a couple 6, 7 vocab things today, but most of them shouldn't be all terrible. So parallel lines are lines that are within the same plane that don't intersect. And we use that symbol, that little triangular symbol on the lines to show that those two are parallel to one another. Eventually, when we get to some of the shapes and things, what that just means, see how one set has one triangle, the other set has two of them? Yeah. That just means, it's kind of like how tick marks work. Those two on the left and right sides are parallel, the ones at top and bottom are parallel. You can have multiple parallel pieces within diagrams, just like you can with tick marks. Parallel doesn't mean that they're congruent, it just means they just don't intersect. And go along with what's parallel is another term called skew. Since we just got done talking about points, lines, and planes and all those different things, you can actually have lines that don't intersect, but they're not called parallel because they're not in the same plane. For example, real easy one. Ceiling tile grid. It's going east and west. This blue stripe on the floor goes north-south. Barring the idea that the ceiling falls in and hits the ground, will those two lines ever intersect? No, those lines will never intersect. They're never going to intersect, but they're not parallel because they're not within the same plane. They're called skew, right? Lines not in the same plane that will not intersect. Okay, it's really simple. Just because we talk about this idea of what's called parallel, I also want to bring up the idea of what's called skew, just so that way we have another term for things. And then the last quick one here, sometimes it's easier just to draw it. The other one we're going to talk about today is something called transversal. You ever heard of that? No. Transversal. A transversal is any line that intersects two or more lines. That blue line I just put on there is transversal. Find that here. Should we do this?
What does that say?
Transversal. Any line that intersects two or more lines. Real fancy. We use it all the time, though. For our sake, more often than not, when we're talking about a transversal, it's probably just going to hit two lines. It's going to look like that right there on the diagram. It's a very, very common, easy thing to work with. Right? So parallel, obviously, lines don't intersect, same plane. Skew, lines don't intersect, different plane. Something on the front wall, something on the back wall. They're never going to intersect, but they're never they're not in the same plane. So, and the last one then is this thing called transversal. I'll show you what happens. I redraw that. This symbol, oops, redraw here. This picture, that picture right there says a lot. That says two parallel lines are cut by a transversal. That's what that diagram means. Okay. When you look at it and cover up just the bottom, how many lines intersected there? Two. How many angles are formed? Four. Okay. Now, we did this before. If I do something like this and go 1, 2, 3, and 4, what's the relationship between 1 and 3? What is that angle? Where are those angles from? They're vertical. Yeah, the vertical angles. What are 1 and 2? Linear pair. See how 1 and 2 create a line? 2 and 3 create a line? 3 and 4 create a line? 1 and 4 create a line? Those are all linear pairs. Okay? They're supplementary. That means they add up to equal how much? 180. Okay? Same thing goes for when we talk about this. 1 and 3 would have been congruent because they're vertical. 2 and 4 would be congruent because they are vertical. Okay? That goes back to the definitions of things we were looking at last chapter. Those things, especially in math, as you guys are well aware, if you think about it, adding, subtracting, multiplying, dividing, solving 1, 2 step equations, that's stuff that you've learned before you came into here. So math is one of those things that you're just going to keep reusing things that you learn. Okay? Whereas sometimes when you're, let's say like in a history class, if you're learning about World War I, when that war is over, you're done reading about it. You know, it's not. I mean, obviously things, political things, all that come about it, but for the most part, you're learning just about certain states. So same thing here. You guys all agree then that those two are the same and those two are the same, correct? Because of vertical angles. Well, what happens then is that if I keep going down here, how many more angles are formed down there? 4 other ones. So when you number the bottom part here, since I started in the top left spot, correct. I'm going to start in the top left spot of the other set as well because I want to have this specific, what's called correspondence. I want to stay within that same pattern. I want them to go through the same thing. Because now what happens is we're going to get what's called an angle pair relationship. Corresponding angles. Angles in the same position. Angle 1 and angle 5. They're in the same spot. Top left corner. Angles 4 and angle 8. Same spot. Bottom right. 2 and 6. Top right. 3 and 7. Bottom right. So what happens here is this thing called corresponding angles. There's angles in same spot on both lines. Same spot. Another really easy thing. Is that Rouse? That's pretty funny. So corresponding angles in the same spot on both lines. Pretty simple. Okay. What happens to become more specific then is this. We're going to start using what are called if-then statements.
I remember this.
Yeah? If-then, if it's ninth hour, you're in geometry, then you're in geometry. Or if it's ninth hour, then you're in hell. So what we use if-then statements a lot, and most definitions in math are written in this kind of a format. If something is occurring, then something else can be said. Happens a lot. You know, if two lines are perpendicular, what kind of angles are formed? Right angles. If two lines are perpendicular, then right angles are formed. Things like that we use if-then statements for definitions. Well, this symbol means if two parallel lines are cut by a transversal. That's what this says. Instead of writing, because you don't want to write all that out. That sucks. I don't want to write all that. If two parallel lines are cut by a transversal. Can you cut a line in half? How? How do you find the middle of a line? How are you going to find that for a line? You can't. Lines are infinite. You have to have a segment. True, but you're right. We can't see it, but we can make a symbol for it. So basically, this means if two parallel lines are cut by a transversal. If that happens, then a whole bunch of other things will fall into place. For example, first thing I would say is corresponding angles. Be a good idea. Are congruent. Again, angles 1 and angle 5. Those two guys are in the same spot on the same side of the line. That means they're within correspondence. They correspond to one another. Since the lines themselves are what we call parallel, then those lines, those two angles have to be equal. We say that they're congruent. They have equal measure. Things have equal measure in geometry, they're called congruent. Angle 2, angle 6, same spot, same position in the line, parallel lines, congruent, and so on and so on. Yeah. Oh, yeah, it says if two parallel lines are cut by a transversal. Just use that symbol with the arrows all around it. Corresponding angles. It looks like that. That symbol with the arrows on it, you use that. If you don't put arrows on it, what does it look like? Not equal to, right? By putting the arrows on it, it tells me what it is. Okay? It's shorthand that a lot of math teachers use for that. So it says if two parallel lines are cut by a transversal. Don't worry about that. You don't ever have to write all those words out. I was just saying that's what I meant. Textbooks even use that symbol because it just takes too much time to write. What's that? We try our best to get away with as much as we can. Another one that happens. Another thing that happens is we get one that are called alternate exterior. Okay. Now, go back to our number system here. We have 1, 2, 3, 4, 5, 6, 7, 8. When we have a diagram, you either have angles that are on the outside of the lines and angles that are inside the lines. You know, find that? Where are the two lines that are parallel? Your two parallel lines are these two guys, right? Okay. So you either have lines, watch it. You either have angles that are on the outside of it or the inside of it. Outside. Outside. Those are outside. There's the bun. And then the inside is the burger. Sure. All right. Not bad. What's that? I just hit the back button. You put it back if you want. So again, we have ones that are called alternate. Oops. Can't write today. Alternate exterior angles. All right. Exterior. Yes, ma'am. Yeah, we'll have those for those two. So alternate exterior. When you say alternate, we're talking about this whole thing with that transversal. So what happens is you got your two parallel lines that are cut by a transversal. When that happens, angles that are on the outside on opposite sides are also congruent. So in my diagram here, see how angle 1 is an outside angle. It's on the left-hand side of the transversal. 7 is on the outside, on the right side of the transversal. They alternate sides on the outside. So what I would say is alternate angles are outside angles, opposite sides. Opposite sides on the outside. Okay. When they're parallel like this, so we have alternate. Opposite. Yeah. Yep, that's right. Opposite side on outside. Yeah, when I say opposite side, it means opposite side of that transversal, and then on the outside. So in our numbered one, because not all of them are numbered, 1 and 7. What's the other set that'll be exterior? Yeah, the exterior with 2 and 8. Okay. Now, what's that? So you get the idea where you get opposite angles on the outside. If the lines are parallel, corresponding or congruent, and alternate exterior congruent as well. And you were alluding to alternate interior. Alternate interior, what do you think those would be? Yep. Alternate interior angles. Those are going to be opposite sides, inside. Opposite sides of that transversal, inside. For example, 4 and 3 and 4 and 6, 3 and 5. Okay. 4 and 6, and then 3. I gotta do double here. 3 and 5.
Okay, so the alternate interior angles are
Inside, opposite side. Yep. What's that? Yes, sir. And that's where all this is getting to. As you start walking around, and I'll show it on a clean one here in a second, you're either going to be equal or supplementary, no matter what. And what I mean by supplementary means they're going to add 180. And I'll show you how that works. It just depends on which markings you're making. So these are opposite side. On the inside. Okay. Opposite side on the outside, opposite side on the inside. Okay. Now, when I go, can I go to a clean one real quick to show you something? What happens then? No, all right. Mm-hmm. Yeah. Yep. And I'll show you how all this happens here in a second. Let's draw another clean one. So when you get in here with a clean one, then right there, I have two parallel lines that are cut by a transverse. Okay. And when I have that, I get 8 angles. Of those 8 angles, more often than not, you're only going to have 2 different measurements. Okay. For example, if I say that this angle here is 105 degrees, I can go through the diagram using angle pair relationships to show what other angles there are 105. First thing we know is it's vertical. You knew that from last chapter. The vertical angle here has to be 105. We just learned this one, alternate interior. Right now I'm on the inside on the right side. If I switch sides to the inside to the left side, I'm on the other side of it now. That's 105, isn't it? Doesn't that also match up between here and here? Yeah. Would they be corresponding then too, wouldn't they? Which means then I use vertical, and this is also 105. Now, as you go back through all this, what angle pair is that? Alternate exterior. Are those the same numbers? Yeah, they're congruent. Those two are, they're congruent, yes, but they're corresponding. They're in the same position. All right. Same thing here. I go to here, those two are alternate interior. All right. So what happens is you're only going to get 2 separate angles. Now, you can easily figure out what the other angle is. What does it have to be? It has to be 75 because angles that are next to each other that create a line, linear pairs, always add up to equal 180. Again, 75, switch over, 75, and switch back 75. The only other one we have to talk about is when they are on the same side. Let's see, do this. Put some tick marks in. When they're on the same side on the inside. If I look at that, when they're on the same side on the inside, that means those two, same side inside. What do those two always add up to equal? 180. So those are called consecutive interior. Consecutive interior. This is the last one, I promise. I think so. I'm pretty sure. Consecutive interior bless you. Same side inside. Always add to 180. Same side inside. They will always add to 180. Always. Okay. So the fourth and last one that we talk about today are what you call consecutive interior. Consecutive interior angles. They're not congruent. They add to 180. We say they're supplementary. Supplementary means added 2 angles added 180. Complementary would be 2 angles added 90. Okay. Now, in this last diagram, see how I kind of overdid it with the tick marks? Notice how if they have the same number of tick marks, they're equal. 105, 105, and so on, 75, 75. What happens when one of them has 1 tick mark and the other one has 2? Not necessarily. They just, what do they add to when they're 180? So no matter what, when you mark your diagram, you're either going to be equal or add to 180. No matter what. Okay? So when we start looking at problems here, it's not so much We still need to know what certain things would be equal. But what we can do is stuff like this.